So another topic close to my heart, coffee, and not getting enough coffee. So let's have a look at this question now. So we're testing the hypothesis that the machine is not dispensing enough coffee. The null hypothesis, though, will be that the machine is working perfectly normally. There's nothing unusual happening. So the null hypothesis, described in terms of numbers, is that the mean amount of coffee is 320. The alternate hypothesis is that the machine is dispensing too little. The mean is less than 320. And so this is a one-tailed test. It is a one-tailed test because the customers are complaining that they're not getting enough. Okay, so if we define the random variable x as the amount of coffee dispensed into a single cup, then under the null hypothesis, the distribution of x is normal, mean 320, variance 10.6 squared. But the distribution of the sample mean, x bar, will have a slightly different probability distribution, and the difference is that the variance is divided by the sample size. So the variance of the mean of a sample of 10 cups will be 10.6 squared over 10. So that means the standard deviation will be the square root of that. So this gives us a little picture of the distribution of the sample mean. And it's got a mean of 320, the same as the mean of the overall population. But the standard deviation, as I said, is the square root of 10.6 squared over root 10, which is about 3.4. So this number down here will be 320 minus 3 lots of 3.4, around about 310. And then what we're trying to do is we're trying to find the probability of the mean volume of coffee being 315 milliliters or less. So 315 would be around about there, somewhere between 310 and 320. And we're trying to find that probability. So what is that probability? We're using a lower figure of, well, I would use in my calculator, a lower figure of minus 10,000, be absolutely safe. This would be my upper figure, that's my mean, and that's my standard deviation. And that gives me that the probability that x bar is less than or equals to 315 of being that number, 0.0679. Now that's quite a small probability, and the probability that a random sample of 10 cups gives you a mean of 315 or less is quite a small number. But how small does it need to be for us to reject the null hypothesis? Well, that's the answer there, 5%. It's not small enough. It's bigger than 5% or 0.05. So we haven't got enough evidence to reject the null hypothesis. And so we haven't got enough evidence either to conclude that the machine is dispensing too little coffee. So that's the hypothesis test completed for part A. Now we look at part B. We've got a capacity in a cup of 350 milliliters, and if the machine's working properly and dispensing a mean of 320, what's the probability of a cup being overfilled? It's a single cup now. So now we're looking at this distribution here, the amount of coffee into a single cup. So we're looking at X, the distribution of X, normally with a mean of 320 and a variance of 10.6 squared, so a standard deviation of 10.6, and we get the probability there of being greater than 50 be 2%. So there's still, some customers are going to be getting cups which are overfilled, spilling out, which is a bit of a problem. We've got some customers at one end saying they're not getting enough, and we've got a small number of customers who will be getting too much. So really, what's the problem here? I think it's not the question of the mean necessarily. The problem is the standard deviation. It's a huge standard deviation, really, and that's the problem with this machine. It needs to be tightened up so that it's more consistent, and then perhaps everybody would be happy.